Okay, so the product of powers property, basically what this is going to come down to is what each of these things mean, right? When we say 3 squared times 3 to the 4th, okay, and I want you guys to listen to the way I'm saying that too. It's not 3, 3, 2 or something like that. It's not 3, 4. It's 3 to the 2nd power, or it's 3 squared. Right? We have a name for that one. The other one would just be 3 to the 4th or 3 to the 4th power. Okay, we don't have a specific name for the 4th power, like with square, we have cube. We don't have another name for that. Okay, so it's 3 squared times 3 to the 4th. And what does that mean? Well, 3 squared means 3 times 3, right? And 3 to the 4th means 3 times 3 times 3 times 3. And what are we doing with those two things? Well, we're multiplying them. Well, when I look at that, what's happening there, right? It's 6 3's multiplying together. Well, what do we call repeated multiplication? Well, that exponents. Well, what's my exponent here? Well, it's just a 6. Okay. Yeah, 3 to 6, right, Tatum? Right? So 3 squared times 3 to the 4th is 3 to the 6th. Okay? I want you to note that it is not 9 to the 6th. Okay? Pretty common mistake students make is that they think that they need to multiply the 3's, right? It makes sense. It says 3 times 3. Why would I multiply the 3's and get 9? It's just not how it works. Okay? We can't do the 3 multiplication and the exponents at the same time, because then we get a completely different number. Okay? So 3 to the 6th does not equal 9 to the 6th. So we do not multiply the 3's. Okay? Right, so same way, the next one. What's x to the 4th mean? What's x squared mean? What does x mean? Well, x to the 4th means x times x times x times x. X squared means x times x. And x means, well, x means x, right? It's just an x, right? There's a 1 there, right? We don't write that 1 exponent, but it's there. So I just have 1x. And those are all multiplying. Yeah, right, Tatum. X to the 7th, right? How many x's are there? There's 7 of them. What are they doing? They're all multiplying each other. So it's x to the 7th. Okay? If those were pluses, if it was plus, 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 that would be 7x. Okay? But since it's multiplying, that's x to the 7th. Repeated multiplication is an exponent. Okay? So this is x to the 7th. Well, what did we do? Is there a shorter way to think of that? Here, take a look or something. Is there a shorter way to do that, right? From where we started to where we ended up. What's it look like happened? Where we started, where we ended up. Yeah, right, Jasmine, just add up the exponents. 2 plus 4 is 6. 4 plus 2 plus 1 is 7. Just add the exponents. So the little rule up here, a to the m times a to the n. So here I'm saying a to the m, or a to the mth times a to the nth would be a to the m plus n. Okay? When it says multiply, we add the exponents. Okay? What doesn't happen here, notice that part of the reason this happens is because those were both 3's to the something. Those were all x's to the something. If we mix numbers or something like that, if it was like 3 to the 5th times 4 to the 2nd or something like that, that does not equal like 12 to the 7th or something like that. Because those are different numbers, we can't do anything with the, since those are bases, the 3 and the 4 are different, we can't combine them. We can't do anything like that. The same way, like x to the 4th, y to the 5th doesn't equal like xy to the 9th or something like that. Like those things don't mix. Yeah, they got to be, yeah, it's kind of like not like terms, Tatum. That would be a good thing to type in the public chat. The bases have to be the same in order for the powers to combine. Okay, so if it's an x and a y, that's all it is. That's all I can do. X to the fourth, y to the fifth. That's all I can say. 3 to the fifth, 4 to the second. That's all it is. I could tell you what that's equal to as a number, some giant number, but I can't combine it and get something else. Okay, they have to be the same in order to do that. Right? So when it says multiply, we add the exponents. Make it easy. Okay? Don't worry, Brooklyn. Okay? Next one's called power of a power. Again, I'm not super interested in you guys knowing the names, but that's what it's called. Notice how we have now a base with an exponent on it inside parentheses with another exponent, right? So it's an exponent on an exponent, right? An exponent on an exponent. This goes to the essential question: how do you square a cube? How do you cube a square? All right? How would I say this? This is 3 squared cubed, or 3 to the second to the third, or 3 to the second power to the third power. Okay? I use that word to the, or that phrase to the. When we're talking about powers, we're talking about to the. Okay? 3 to the second power, 3 x to the fourth power. Right? What does it mean to cube something? Right? Well, it means to take that thing and multiply by itself. Even if that thing is something more complex, like 3 squared, we still take that thing and multiply it by itself 3 times. So that'd be 3 squared times 3 squared times 3 squared. What did we just say happened when we multiply powers that have the same base? When it says multiply, we would do what? What did we just say? And we add them, right, Connor? Okay? So 2 plus 2 plus 2 is 6. Okay? So 3 to the 6th. When it says multiply, we add the powers. So we take this new problem and we turn it into a problem that we already know how to do, and then we apply that rule. So x to the fourth to the fifth means to say x to the fourth times 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 x to the fourth, right? 5x to the fourth. But what does our rule tell us to do? Right? Tells us to add, yeah, right, Tatum? Okay. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. Right? So what's the shortcut? Right? How can we do it faster so that we don't have to sit here and write it out? So that if I say, hey, what's 7 to the 12 to the fifth, or I switch that around. 7 to the fifth to the 12th. Right? I don't want to write out 12, 7 to the fifths. Yeah, right, Tatum, right, Ty. Multiply the exponents. Okay? 2 times 3 is 6. 4 times 5 is 20. So when it said multiply, we added, right? But when it says power to a power, we multiplied the exponents. So we've got to watch, right? We can't do what it says. We have to kind of take a step back. It said multiply the powers, so we added their exponents. It said take the exponent to another exponent, so we multiplied the exponents instead. Okay, we see that's how it's working. We want to internalize that shortcut. We'll talk about it that way so that we don't have to sit here and write it out over and over again. And right, Tatum, yeah, it's 7 to the 60th. Okay, I don't want to write that out 12 times. I just multiply those two numbers. 7 to the 60th power. Okay? So there's what you guys really should be doing. It's just saying, oh, this is a power of a power. I'm just going to multiply those exponents. Okay? So we look at that little thing up there in the black, that a to the m to the nth means a to the m times n. So we multiply those exponents. Again, notice that the 3 didn't change. It's still 3 to the 6th. The 7 didn't change. It's still 7 to the 60th. The base isn't changing. It's the exponents that are changing. Right? We're working with our exponents right now. Okay? Again, I'm showing you guys how it works, but I want you to do the shorter way. Okay? I'm showing you why it does what it does. I want to do it the shorter way because I don't want you writing out over and over again. Okay? So I'm going to keep showing you that. Here's why it does this, but then we're going to talk about how to do it faster. Okay? Anything on these first two you guys want to talk about? We'll move on to the next one. Okay. The next one's called the power of a product. It's essentially like the last one we did, except for just notice that what's inside the parentheses now is more complex. Like there's multiple things. There's a 3 and an x inside of there, or there's a 4 and an x cubed and a y in there. So there's just more stuff inside the parentheses now instead of just one power. There's multiple powers inside of there. Okay? But we're going to approach it that same way. Okay? Looking at what does it mean to take something to the 5th power? Well, that means I write it out 5 times, multiplying it each time. What do I have here? I have 5 3s. So that means I have, not quite Tatum, 3 to the 5th. I also have 5 x's, which means that's x to the 5th. Okay. You guys will be asked to do 2 different things, okay, as far as instructions go. One thing, this problem, I would just ask you to simplify this, okay? So I'm just asking you to simplify this problem. So going from 3x to the 5th to 3 to the 5th, x to the 5th, okay? So there it is, simplified. The actual correct way to say this is the quantity 3x to the 5th. That way you're saying that it's the 3 and the x are both being to the 5th power versus if I just say 3x to the 5th, that's what that means. 3x to the 5th is that purple one there. The quantity 3x to the 5th is this one. That's how you would say that. That's how you differentiate between what has parentheses and what doesn't verbally. Okay? So that's one thing you would be asked to do is just simplify. Okay. On this next one, all right. Yes, Tatum, right. Tatum's charging ahead. So again, what does that mean? It means 4x cubed y. If when you're writing this, you want to spread things out a little bit, it's probably good for your eyes, so they're not all smushed together like the typing does. You don't want to be like 4x cubed y like that. If you need to stretch things out a little bit so it's not all mushed on each other, go for it. Okay. Times 4x cubed y times 4x cubed y. And again, that is a kind of idea. Like, look at each thing, right? I have to look at the ones that are like each other. You guys mentioned like terms earlier. So I can look at the 4s, right? And say, well, how many 4s do I have? Well, there's 3 4s there. That's 4 cubed there. And then I look at the x's. You gotta be careful, right? Those are all multiplying. Everything here is multiplying. There's little dots here, 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 here. That's all multiplying, right? We just don't put those dots there. When it says multiply, what do we do? When it says multiply, what do we do? Add, right, Elijah? Add the exponents. So I have a 3 plus a 3 plus a 3 is 9. X to the 9th. Okay? And then I have a 1 here, and a 1 here, and a 1 here. 1 plus 1 plus 1 is 3. So the other thing you'll be asked to do is simplify and evaluate. So as far as simplifying, that's this. Evaluating, right? Value, find the value of. The only thing there we can find the value of is the number. We can't figure out what the value of x to the 9th is. Why did I write y to the 9th? Who let me do that? I should say y cubed. You guys are supposed to be on top of me, come on. Should we change that? I should say y cubed. I can't find the value of x to the 9th. I can't find the value of y cubed, but I can find the value of 4 to the 3rd. So the value here, 4 times 4 times 4 is 64. So if you're asked to do those two things, we are expecting to see both of those answers. Okay? That you're showing us that you understand how to do with the powers alone, and then you can also give us a value of a particular number. We will generally not do this with larger numbers. Like I wouldn't ask you to evaluate 3 to the 5th. One, most people don't know what 3 to the 5th is off the top of their head. There's no real reason to. And it's also a pretty big number. Okay? But it's going to be things like small cubes, like 4 cubed. One, you should probably kind of know that by now, if not be able to find it very easily. Or, small to larger squares, like 12 squared. You really should know what that number is by now. Okay? It's not going to be 8 to the 7th power. Evaluate that. Okay? So it'll be small cubes and small to larger squares. If you think about last semester, we talked about knowing your squares up through 15, and knowing your cubes up through 10. I think you should know that 10 cubed is 1,000 is a good idea. So again, not asking you guys to memorize those, but kind of suggesting that you should. That it'll make your math life a lot easier. All right. Same thing here in this last one. So I'll just be 2a squared b c cubed times 2a squared b c cubed. Again, that idea that you can kind of, if you need to visually kind of pull things apart, and again, just realizing that that square is not on the 2, it's only on the a, and that cube is not on the b, it's only on the c, right? And so as I look at this, 2 and a 2, that would just be 2 squared, right? Because there's a 1 right here and there's a 1 right there, and I add those 1s. I get 2 to the 2nd power. And 2 a's and 2 more a's gives me 4 a's. 1 b and another b would give me 2 b's. And then 3 c's and 3 c's would give me 6 c's. And we're always adding when it's multiplying, right? Multiplication means we add the exponents. So there's the simplified version. If I asked you to evaluate that, you certainly should be able to. 4a to the 4th, b squared, c to the 6th. Simplify and evaluate. That's what we're expecting to see. Okay. So how could we have done that without having to write it out over and over again? Can we see the pattern? How are things acting so we can just do it faster? You see a pattern, Jacob? You see a pattern, Julie? How we go from here to here without doing any of this middle stuff? How could we have gone from here to here without doing any of that middle stuff? Multiply what? Multiply the exponents, right? So Julie's saying multiply the exponents, but I also got to think about it. You multiply all the exponents, and we think about multiplying across a whole bunch of stuff. What do we call that? We have to multiply across a whole bunch of stuff. What do we call that? you take one thing and multiply it to a whole bunch of things. What do we call that? Distribution. It's like distribution. I don't want you guys to call it distribution, but it's like distribution, okay? It's like distribution. I take that m and I kind of like distribute it to the a and the b, okay? So that would just be a to the m, b to the m, right? That 5 got distributed kinda to the 3 and the 5, right? The 3 got distributed to the 4, right? It's 4 to the third. As I do distribution, right? It's multiplication. Distribution's a multiplication idea, right? 3 times 3 is 9. There's a little 1 right there. 3 times 1 is 3. Oh, that's all it is. Right? There's a little 1 right here. 2 times 1 is 2. Oh, look, there's a 2 there. There's a 2 here. 2 times 2 is 4. Oh, look, there's a 4 there. There's a little 1 right there. 2 times 1 is 2. Oh, look, there's a 2 there. 2 times 3 is 6. Oh, look, there's a 6 there. Okay? It's like distribution. Why I keep saying that is because I do not want you guys to screw this up. This is something we talked to you guys about last semester, and something that happens every year. Right? How do you do that? Right? It's so important that you keep that skill correct, that does not mean x squared plus 2 squared. And we already had to fight some of you guys last semester about doing that. Okay? What that does mean is x plus 2 times x plus 2, and then you have to go through and do the FOIL. And I don't want you guys to screw up something we worked on last semester because of what we're doing right now. Okay? Squaring something always means multiply by itself. Okay? That's what it means to square something. Multiply that thing by itself. That's what we did. I'm trying to show you a faster way to do certain types of problems. Everything here says multiplication, right? Multiply, multiply, multiply. This says add. It's a different type of problem. I can't do that same shortcut here that I can than I could here. This is all multiplication. I can think about that as like distribution. As soon as that's a minus or a plus there, you've got to stop and say, what does it mean to square something? It means to multiply by itself. That's how I have to attack this. Okay? And that's what that means here too. I'm just trying to show you a faster way. Okay? For problems that look like this, we can do those faster. It's just like I taught you guys AC method. I'm like, oh, but there's some AC method problems we can do in this difference of squares. And it's so much faster. Let's pay attention to what they look like. And if they look like this, we're going to do it this faster way. If they don't look like that, then we have to do it the original way. It's that same thing. Okay? The problem looks different. There's something fundamentally different about it. We can't do them all the same way. Or there's a faster way to do some of them. We could do them all the long way. Let's try to find a faster way through some of them. Okay? I don't want you guys to mess this up. Watch out for that. Speaking of messing up, negative exponents is by far the most commonly messed up exponent rule property. Okay? Because you have a natural instinct. Okay? Hey, Jet, if I just asked you what 7 to the negative 2 is equal to, just tell me off the top of your head what you think 7 to the negative 2 is.
49.
It's 49?
Yeah.
So it's the same thing as 7 squared? Okay.
Wait, that might be if it's negative 7. I don't know.
Okay. Let's sort out. Okay. Tatum, what do you think? Just off the top of your head, what's 7 to the negative 2 mean? What's the answer going to be? Do you think it's 49? Yeah? Julie, what do you think? 7 to the negative 2, what do you think it's going to be? We have a negative exponent now. What's it going to do to our problem? You guys think you're positive? You guys aren't doing what I think you should. Peyton, don't be a butt. Who thinks it's going to be negative 49? If 7 squared is 49, why wouldn't 7 to the negative 2 be negative 49? Was that really? Is there 2 negatives? 7 to the negative 2. This isn't a negative. Right? It's not 2 negatives being multiplied by each other. 7 is the number we're multiplying by something else, right? By 7, right? what's the negative exponent do? I mean, you guys are being weird, but I'm not saying negative 49. That's what most people would say that I've run into. Okay. Well, I'm just surprised you guys aren't saying that. But still, that instinct of it being negative is wrong. Okay. And what you guys are your instinct here with this of getting 49 is also wrong. So you've got to, either way, there's still some natural instinct you guys have to get an answer that's wrong. And so we got to make sure we fight that. Okay. Really what this is, I think, and sometimes we misuse the word negative. Okay. Really what this is the opposite or the inverse of an exponent. Okay. And if an exponent is repeated multiplication, like 3 squared means 3 times 3, then the opposite of that, the inverse of that, would be repeated division. So if I want to say 3 to the negative 2 or 7 to the negative 2, that means divide by 7 twice. Well, where does division happen? It happens in the bottom of a fraction. 7 to the negative 2 is equal to 1 over 7 squared. It's repeated division rather than repeated multiplication. That's what the negative sign means there, is do the opposite of repeated multiplication. So we're going to do repeated division. That's the simplified version of that. If I then ask you guys to evaluate it, 1 over 49. Okay? So none of you would speak up and say, hey, I think it's negative. I bet some of you probably did. That's wrong. Okay? Negative exponents are fractions, not negatives. Okay? That's the most common misconception, is that they think negatives. So 3 to the negative 3 means divide by 3 times. It's 1 over 3 cubed. I have to put that 1 there because there's nothing else with the 3. There was nothing else with the 7. Technically there is a little 1 here, right? 1 times 3 to the negative 3. That 1 is just sitting there, right? There's 1 times 7 to the negative 2. That 1 is just sitting there, okay? That's the simplified version. If I ask you to evaluate it, it'd be 1 over 3 times 3 times 3 is 27. Okay? Simplify and evaluate. So I would expect to see both of those things from you guys. Okay? Show me that you understand what the exponent's doing and then what's it equal to. Okay? So 2 to the negative 4, 1 over, what happened to the exponent? It became positive. 1 over 2 to the 4th, right, Tatum? Okay? So it moved to the bottom, becomes positive. What's 2 times 2 times 2 times 2? 16. Negative exponents can be really easy, guys. You gotta solidify that idea that it's a fraction, and that you shouldn't have to stress too much about what the answer is going to be. If you ask yourself the right question, okay? When I look at 5 to the negative 2, I don't ask myself what's 5 to the negative 2. Okay? I'm not trying to figure out what 5 to the negative 2 is. Instead, I'm reminding myself that negative exponents are fractions. And then I say, well, what's 5 to the positive 2? What's 5 to the positive 2? 25. So 5 to the negative 2 must be 1 over that. Okay? I don't worry about the negative. I just say, hey, that's a fraction. And then I write my number underneath it. So if I say, what's 10 to the negative 2? What's the question I'm really asking myself? What's 10 squared? 100. So 10 to the negative 2 must be 1 over 100. Okay? You can make it really easy. Right? You just have to remember they're fractions, not negatives. Okay? When you worry about the exponent itself, the positive exponent, say, hey, what's that equal to? And I'm just going to write 1 over that. Right? It doesn't have to be some super complicated thing. Right? So when we start throwing letters and other things in there, right? Now we have two powers here together. Remember earlier when I mentioned that, I had to put that 1 on the top of the 3 cubed because there was nothing else with it, or I had to put the 1 on top of the 7 squared because there was nothing else with it. Now there's something with the x to the negative 4. So as the x to the negative 4 goes to the bottom, because negative exponents want to be in the bottom of the fraction because they're division, or the y to the 4th goes to the bottom, that x to the 4th is just going to stay put. Or x squared. I can't remember why I said that wrong. Okay. I like to think of negative exponents as wanting to move. So if you want to like a little analogy here, right? It's negative. It's not happy. Think about negative meaning that it's not happy. It wants to be happy. It needs to move to be happy. As soon as that y to the 4th moved to the bottom, it became y to the positive 4, right? It became positive, it became happy. Okay? The x squared was already positive. It's happy where it is. It doesn't want to move. Okay? So that's why the x squared didn't move, because only the y had the negative on it. Only the negative exponents should move. The negative powers should move. Okay? The positive ones need to stay put. Okay? At that point, I can't do anything else because they're different variables, they're different bases. They don't combine any other way. So that's it. Okay? There's my answer. In the same way, x to the second divided by x to the negative 4, that y to the negative 4, that y as a negative exponent, it's not happy. It wants to move to be happy. Well, it's already in the bottom. It can't move to the bottom. Okay? Where could it move? But up. The x squared is happy where it is because it's positive. Stays put. When the y moves, it becomes positive. It gets happy. Yes, Tatum. How you feeling about that, Natalie? How you feeling about that, Elijah? Kenzie, how's it going for you?
Good.
So look at this last one here. A to the negative 3. Ooh, that's not happy. He needs to move. B to the negative 1. Ooh, she's not happy either. She needs to move. So they're both negative, so they just flip places essentially. So I'd have b to the 1 over a cubed. You don't write b to the 1. That's silly. The simplest way would be to write b over a cubed. Okay, that's the simplest way to write that. They both switch because they were both negative, and then they're both happy. Right? They're both positive after that. Okay? You never, ever, ever end a problem with a negative exponent in it. If you have a negative exponent in your problem, you have to address that by the time you're done. You're not allowed to leave negative exponents in a problem. Okay? They have to be addressed. Okay? Right? You have to do something with it. In most cases, that just means move it. Okay? So a to the negative m would be 1 over a to the m. Okay? So we need this here. There is a little caveat on this, that a cannot equal 0. Okay? Because if I said something like 0 to the negative 2 power, that would mean 1 over 0 squared, which would be 1 over 0. What happens when we divide by 0? What's 1 divided by 0? No, Tatum, no. Yep, so you're making that's a really common mistake. Hey guys, let's get in groups of 0. Right there, Peyton. undefined. Okay? You cannot get into groups of 0. This is a number that does not exist. It's worse than nothing. Okay? 0 is nothing. This doesn't exist. Okay? This is a unicorn. Okay? This is counting unicorns. Okay? We can't do that. We can't take 0 to a negative number because division by 0 doesn't exist. You can't take 0 to a negative exponent because 0 division doesn't exist. Okay? You cannot get into groups of 0. So, but again, negative exponents is by far the most commonly mistaken property, like where the errors show up the most. Okay, so that's where I like you guys to focus some of your mental energy here, is making sure you're not making that mistake, which none of you did, but of thinking that it's just a negative, right? They want to move, or they're fractions, and that's kind of the way to think about it. The negative exponents want to move, or they want to be fractions. Okay. Zero exponent is another pretty mistaken one. It's actually super easy. It's just kind of like a memorization thing. Anything to the 0 power is equal to 1. You got to fight yourself trying to tell you that it's 0. Okay? The 0 exponent is 1. Anything to the 0 is 1. So 3 to the 0 is 1. 427 to the 0 is not 0. It's 1. Okay? Negative 12 in parentheses like that. The 0 power is 1. Negative 12 without parentheses is negative 1. This is an order of operations issue. The negative happens at the multiplication level. The exponent has to happen first. So the 0 power happens on the 12, and then the negative applies after that. Okay? So that's negative 1. 3 times x to the 0. This means 3 times x to the 0. The 0 is not on the 3. The 0 is only on the x. The 3 doesn't change. Okay? 3 times x to 0 is 3. Only the x became a 1. The 3 stayed put. Okay? If it said this, that would be 1. Because now both the 3 and the x get a 0. They both become 1. Okay? In the same way here, this would be a 0 times b cubed, which would be 1 times b cubed, would be b cubed. Right? So the 0 is only applying to the thing that it's on. Essentially, most of the time, cancels, goes away. Right? If there's something else there, like the b cubed or like the 3, the 1 doesn't matter anymore. Right? On the first 4 problems, when there was nothing else around it, the 1 mattered. As soon as we have something else there, the 1 just can go away. We won't need it. Okay? That's a really common misconception about what 0 power would be. Makes sense. You see a 0, you think it's going to be 0. Okay? But it's not. It's 1. Okay? It's really easy. It's just essentially like vocab. You guys just need to know this. Anything to 0 power is 1. Except a cannot equal 0 again. Okay? 0 to the 0 power is undefined. Okay? Yeah. A can be anything else. It can be negative 1 billion. It can be 1.7. So 0 power is 1. Okay? You can't take 0 to 0 power. Anybody need more time there? Next one's quotient of powers. This one's really going to relate right back to the first thing we did. So this one's really easy. I'm going to write this one out first. The first time, I'm actually going to change this real quick. Say x to the 7th over x squared. Okay? So that equals x times x times x times x times x times. I don't know why I did 7. That was all over x times x. This is a fraction. We always talk about reducing fractions. I can take an x out, take another x out. What am I left with? 5 x's. That's x to the 5th. How did we go from x to the 7th over x squared to get x to the 5th? What did we do? How do we go from 7 and 2 to get 5? Yep, we subtracted the exponents. This is just a to the m minus n. Right? When it said multiply, we added. So it should be kind of natural. When it says divide, we subtract. It says multiply, we add the exponents. And it says divide, we subtract the exponents. Okay? So with something like this, x to the 2nd minus 5, always start with the numerator first. Order matters with subtraction, right? 2 minus 5, x to the negative 3. Remember I said earlier, never, ever, ever, ever leave an exponent that's negative. What do negative exponents want to do? What do negative exponents want to do? Move. They want to move. They want to be fractions. Okay, so 1 over x cubed. Okay, I don't need you guys writing it all out. If you want to, you can. But this is really what you guys should be doing. Okay. This one here would be, you just kind of break it into chunks. This would be x to the 5 minus 1, right? There's a little 1 down there. And then y to the 6 minus 2, which of course is x to the 4th, y to the 4th. Okay, look at each variable independently. Do the x's part, do the y's part. Don't try to do it all at once. Okay. So one last thing I need to show you guys real quick. Sorry, over time. I just get so excited about exponents. I talk too much. Last one is very much like the second thing we did. So it's really pretty easy. All that happens is it's like distribution. So 2 to the 2/7 to the 3rd power would just be 2 cubed over 7 cubed. Okay, it's really, really straightforward. So just that you can do this over a fraction also is all we're trying to get at. So this equals 2 cubed over 7 cubed. Okay, there's nothing crazy going on here. That would just be 4 to the negative 3 power. Or these just multiply b to the negative 6. Okay, all I'm doing is multiplying. There's a little 1 right there, so I just multiply the 1 and the 3, negative 3. Okay. And our negatives don't like where they are, so they move. This would be b to the 6th over 4 cubed. Okay. That's horrible handwriting. I apologize. So you guys have your assignment. It's in the Google Class. You have your place to plop that. Okay. If you have time to do the little exit ticket thing, I know I went long. Okay, so it might not happen today. But try to do that. You got 15 minutes still. And again, I will post a video later if you need this, to see something again. So